Okay, so where we left off yesterday, we had just finished the initialization process for the model. So I'm just going to go back here and load it up again. Okay, and you can see here in the reporting it said, okay, it's done all the material assignments and then it's applied conditions. So you can actually have a look at these conditions by looking at the plot file. And I'm going to add again, not attach conditions, those are attachments between subgrids. GP fixities. So the grid point fixities is what I'm going to have a look at. You can see that we have normal fixities applied to each surface, just as we wanted. Top and bottom. Sometimes it's easy to get confused here, so I'm just going to add, I think under miscellaneous, we've got axes so that I know which way I'm looking, which is the top and the bottom of the model. So obviously we have grid point fixities applied because we're applying velocities up here. And I look down here. You can also see I've got fixities at the bottom. So just some quick words about how to navigate this thing. In fact, let me get to that later. When we're going to do plot files next, so that'll be relevant. Okay, so again, I'm going to borrow from another file. I usually have a routine called plot setup, and here it is. And there's quite a few things set up in this file. I'm not going to use all of them. I'm just going to copy it all across though. This is the plot setup routine where it sets up the plots, and mostly you'll see this piece of code appearing a lot. Plot item or plot create, or whatever the name is, and then plot plot item. I thought that should be add actually. Let me just check that. Uh, no, plot item create is correct. Okay. So what variables do I want to look at on this plot, and where do I want to look from? So I'm just going to turn off well, I'm going to keep the axes, turn off the fixities. So I'm looking, basically, if I look from this sort of angle, I'm looking at a cross section of what's going on in the pillar anyway. So I don't need a cut plane because this is obviously halfway, the plane of symmetry is your cut plane basically, where you're looking halfway through the model. I'm just going to rotate it into place. Yeah, this is where I wanted to explain a bit of how to navigate in this space. So with your right mouse button, yeah, everything is done by the right mouse button. I do a rotation. And you'll see here in this little view stats window, there's a variable called center. Now that is the center about which I'm rotating. You can see I'm not rotating about 0, 0, 0, which is here. I'm rotating about a point here somewhere, which is 4, 8, minus 2. Okay. So you can change that manually very simply by just going 0, 0, 0. And now it will rotate about this line here. Okay, so the rotation is relative, so you can very easily end up in a position where you don't have a convenient view of the thing. It's easy, I suppose, when you're rotating, when you're rotating about 0, 0 to get wherever you want. But now I want this thing to be vertical, right? So then you use shift and right click, by the way, pans. So now I pan around the model, and you can see now the center is actually changing. The center about which I'm rotating is changing. And what's missing in all of this, of course, is the yaw rotation. So the rotation about the angle that I'm viewing at. To do that, you press Shift and Control, and then you rotate around. And you can see now I'm rotating in a very different sense to what I was before. I'm rotating around the line between me and the center. Okay, so enough on that. Your left mouse click actually does very little in FLAC3D. It does actually have that question marky thing selected now. Probably easier to manipulate things when you don't have that selected and you have the little arrow selected. So this is kind of the viewpoint I want to see from what's going on. So I've got a cross section there. I'm going to make my center at 0, 0, 0 again. And now I've kind of got the plot, the viewpoint I actually wanted in the first place. Okay, so, and you'll see here my rotation. If I want to view this thing edge on, my rotations obviously need to be multiples of 90. So I'm just going to go, that's the closest is 90, 0, and 360 is 0. So now I'm looking directly edge on exactly where I want to be. And you see the only variable that really has a value now is that 90 degrees to give you the angle, and this minus 19, which is the distance away from where I'm looking at the model. But in this case, I want to see both planes. I'm not going to do separate plots for those two. I want to look along the axis of the thing, like that basically. So I'm going to just check if any are close to 90. So I'm going to make 90. I'm going to leave that one where it is, and I'm going to set that to 0. Okay, great. So this is the view I actually want to look at the results from. I want to see what the extent of failure is within the pillar. So to do that, I'm just going to look at, I think there is one I prepared earlier. Yeah, shear strain, shear plastic. That's what I want to look at. Yeah, and this is all kind of set up for me already. So I'm not going to get too complicated and do hundreds of different views. I'm just going to do one plot to look at the shear stresses, and I'm going to do another plot to look at vertical stresses. So if we look at the syntax here, there's a lot of variable set, but we don't necessarily need those. I'll come back to that. Plot item create zone active on. Contour property, so you're contouring a particular property, and the name of that property is strain shear plastic. Cut active on, obviously I don't need that because I'm already cut through the middle. Origin normal, it all refers to the cut plane. I'm going to get rid of that for now. Minimum, maximum, that's quite useful. So this is settings for the contour now. Now the minimum is obviously going to be 0. The maximum I'm going to set to, so there's a variable set there, admin C reef. But I'm going to go back to my material properties and see what, there I have a variable set there, fail strain equals E admin C coal. So that's the strain at which the coal material reaches its residual value. So I'm actually going to use that variable as my maximum, because anything above that is failed, completely failed. The interval I'm not going to worry with so much. The interval determines how many contours are used, so that the colorfulness, if you like, of the contour. And there are a lot more options in this. I'll leave it to the reader to explore further. My plot views, projection, perspective, magnification 1. My center is going to be, let me just check what it is here. I think it is 0, 0, 0. Well, let's set it to 0, 0, 0 and see what happens. Yeah, I get pretty much the same view, so I'll leave it at that. I'll change this back to okay. Yeah, so those are my settings. So if I go here now, I say center is 0, 0, 0. Z mid model, X mid. Okay, so I've actually created a variable here, X mid model, Y mid model, or Z mid model. Those will all come to 0 anyway. mm. And my eye position, I'm not sure where the rotation goes in here. Anyway, we'll test it. Not to worry, we'll test all of this. Let me just check here. Rotation, my eye position. Okay, so here's where I think all I have to do is set center and eye. I don't think I have to set rotations. So I'm going to put these values in as they appear here. You can do some trigonometry and work out, where is this to get this rotation of 55 degrees. What does my eye position have to be relative to my 0 position? But it's much of a muchness in this case, unless we're going to do huge variations in the size of the model. So I'll just change that to an explicit value of minus 12.2. minus 8.5. Minus 8.5, and that's 0 effectively. Okay. Which is Z mid model again. Okay, I can leave it at that. So I want to test this, so I'm going to leave the where I have FSZZ on. I just want to keep the syntax for that, but I don't actually want it to do this plot. Plot create blank. Initially, when I was running these things, I would always revert to a blank plot, so that when as it cycled, it wouldn't try and update the screen. Well, I might as well keep that there. And I'm going to run everything again. Now you'll see it will create this thing called EP shear, which is a plot file. And I'm happy with that. It's pretty much the same view as we have here. Pretty much identical. Now there's another way to do this. Once you've got your view set up the way you want, and you can even set up the variables you want. Let's say I want to do something else. I want to put, yeah, you can change all of these things here as well in this plot item list dialog window. Zone, property, shear, strain, plastic, blah, blah, blah. I go up here. Oh, and the options for that appear here. So it's contour, property, strain, shear, strain, plastic. Let's say I wanted to look at strain, tension, plastic. Slightly different plot. I'm not sure what the variable name is. Actually, it's going to be this variable name, but what I could do then is export all of this to a data file. I select any old name, make it a text file. I don't think I need to convert. It opens the file up in Fish in the Flax 3D window. You can also do all your editing of your data files here as well. It very helpfully highlight. Well, it's a text file, so it probably doesn't know to highlight the. Let me see. Tools, options, edit. Okay, I don't have time for all of that. But you can see here it's done everything. All the commands are here to create this plot. You don't need all of these commands. And of course, sometimes you want to tokenize things. So here it's actually put a center of 5.55. Is that right? Okay, I'm not even going to mess with that. As I said, these things look identical to me. Angles are slightly different, but anyway. Okay, so you can copy and paste all of this straight into your routine that creates your plots. If you couldn't be bothered with going the long way around. Okay. So I'm just going to undo this, set EP shear, and I'm going to just put SZ. I'm going to have it the same angle. So it's this part here that defines what I'm plotting. Contour, stress, quantity. Yeah, so it's a contour of stress. What quantity of stress? ZZ. Stress off. Okay, that's, I can't remember exactly. Method of, it's an averaging method. No fluids. Average null, not sure what that is. Fluid off, mechanical off. Yeah, this is done using that method of saving the plot file as a data file, and you get quite a few spurious bits and pieces. I'm not actually sure what some of these things actually mean. So here I've imposed a minimum and a maximum. Well, let me get rid of the cut plane again because I know I don't need that. And those three dots. Always remember, if you've got three dots, it'll go to the next row, and then if it encounters the word plot, it's going to bomb out. So I've set variables here to control these things. I said minus 256. So if you don't set minimum maximum, it'll change the contour values for every plot according to the maximum and minimum values. So it's always better if you're doing a some sort of progression. So I'm going to squeeze this thing and see how the stress changes. To do that, I should obviously keep the contour values the same. So what I've done here is I've said minus 250. I don't think it's going to be that extreme. Let's say 50 MPa. Our maximum is 0. That makes sense. I don't want to see, I'm not interested in tensile values where they occur. The number of SZ int, max minus min over number of contours, and I've set it to 25, which is a bit higher than the default. Yeah, let's make it 30, make it really pretty. These other variables, it doesn't look to me like I actually used. Yeah, we can always come back and change those things. So let's run it again, make sure everything's working. Yep. Oops, nothing there. Active on, contour stress, quantity ZZ. Let me get rid of all these switches. Minimum, maximum, interval. Oh, of course sorry, the view is all over the place. I forgot to change the view back. So all I do is I copy, if I want the same view, I just copy that, plot view projection, blah, blah, blah. Put it here, save it, and run it again. And there we go. And it set it from 0 to 50 MPa. Fantastic. So that seems to be working. I just want to do one more routine before we go to the next thing. Again, I'm going to shamelessly copy. And that's the do plots routine. So even though we've created that file, it doesn't do anything at this point. Well, it creates the plots, but it doesn't output them. So that's that I'm going to do here. I'm going to say, so I need a file name. So along with things like Xmin models, Zmin model, there's a variable I use throughout these models, which is called stage name, and that basically applies, and it's a string which gives. There's usually a counter that I then convert to a stage name, and that will then give me. That'll add to the file root, which is the name of the problem, plus whatever the plot is, plus a stage name, plus then obviously the extension. So I'm just going to call that plastic shear strain. I'm only going to output 2. And SZZ. Yeah, that's all I need. So all I've got is okay. So then to output these as files, I just plot whatever the name of the plot is, export bitmap file name, done. So I just need to copy the name of the plot I want, the file name, I'm just going to call it PSS and SZZ, nice and simple. There it is. And every time I run this routine, it will come in here, obviously, and then it gets here. It said fname PSS, file root, blah blah blah, stage name. Stage name will have changed between this call and the last call. So you'll get a sequence then of output files, hopefully numbered based on some sort of counter. Okay, time for a short break again.